Hello everyone, this is Dr. Manjunath Chennapkot from Anveshana Academy, Bangalore, India. I welcome you to my YouTube channel Anveshana Academy. Dear students, in the previous class we were discussing about what is reversible process, irreversible process, what are the examples for reversible and irreversible process. In detail we have discussed. And also we discussed what is thermodynamic flow process and what is thermodynamic non-flow process, and what are the examples for both we have discussed in detail in the previous class. Dear students, come we will move towards next topic. So our next topic is thermodynamic, cyclic and non-cyclic process. Thermodynamic, cyclic and non-cyclic process. Okay, so now dear students, what is thermodynamic cyclic process? That you can see here now. First I will read the definition and I will explain the definition of thermodynamic cyclic process with the help of some examples. So now, what is thermodynamic cyclic process? You can see here now. A cyclic process is a thermodynamic process in which the system returns to its initial state after a series of changes. Okay, this means that all the state variables like pressure, temperature, volume of the system are the same at the beginning and end of the process. Okay, so I repeat, thermodynamic cycle. What is the thermodynamic cyclic process? Thermodynamic cyclic process is a thermodynamic process in which the system returns to its initial state after a series of changes. That is known to be thermodynamic cyclic process. How it is? You can see here now, dear students. Now you can take a system. That system is going to revert, or it is going to returns to its initial state. Initial state even after gone through a series of process. One thing where the state variables will not change initial as well as at the end. That means what? All the state variables maintain identical. That means what? They remain same at beginning and end. At beginning and end of the cycle. One thing. And cyclic integral is 0. That means what? The change in any state function over a complete cycle is 0. That means what? The net change is 0 in the cyclic process. Okay. So what is cyclic process? When a system undergoes a series of states, right? Series of states. It is going to return to its original position or initial state, where the properties of the system are identical at both initial state and final state. That type of process we can call it as a cyclic process, dear students. Now, what are the examples for this cyclic process that you can see here now? Okay, so now to understand better, I will try to take one PV diagram and one diagram. I will try to explain you what is cyclic process here now. Assume that, dear students, there is a delivery truck, right? Now it is at initial state now. Then the truck or system will move from one state 1, or you can call it as the initial state or initial point, and it will reach point 2. Then it becomes what? 1 to 2. It is a process now. It is a process but not a cyclic process. If the truck is again, it will come from point, it will move from point 1 to point 2. Then again it will come from point 2 to point 1 again. That means what? This is what initially when it is started, right? That is the initial point. When it is going to reach, right? That is a final state. That means what? The properties, the state variables of the system should be remain same as per the cyclic process definition. That means initial pressure, I will take it here now. The properties of the system. Initially the property of the system is Pi. Then when it reaches back to its original position, right? The properties of the system remain same. That means what? You can take pressure at the final state. That means what? Initial pressure must be equal to final pressure. That means the system undergoes a series of states now. 1, 2, 3, 4 like that. A number of states it passed and it came back to its original position, but the properties like pressure, temperature, volume remains same. That means what? If it is initial volume Vi, then final volume remains same. If it is temperature initial Ti, then final remains same. That means what? A system, the cyclic process is thermodynamic process in which system returns to its initial state after a series of changes. That means what? After a series of changes, that means the state variables like pressure, volume and temperature are same at both initial and final state. That is known to be thermodynamic cyclic process. What are the examples that you can see here, dear students? Now you can take a Carnot cycle, you can take a Rankine cycle, you can take a diesel cycle, you can take a Otto cycle, dear students. Now when it comes to Rankine cycle, right, so what it is going to have components: boiler, turbine, condenser and pump. How it is a cyclic process, that I will explain you here. Okay, now you can take Carnot also, it's a cyclic process. Rankine also we can take it as a cyclic process. Now how it is cyclic process, that you can see now. Then boiler is a system, dear students. It is going to consist of what? Initially it is going to have a water. That water will be heated, then water is going to convert it into steam. Then that steam is going to pass on to the turbine. Then work we are going to get, that means what? We are going to get the electricity from the turbine. Okay, once the work is done, whatever the steam is there, right, that will come out from the turbine. Then we are going to pass on to the condenser or heat exchanger. Initially it was water. Because of heat addition, water is converted into steam. Then that steam is expanded on the turbine. Work is done. After work done, whatever the steam is there in the turbine, right, we are going to take it out. Then we are going to pass on to the condenser. In the condenser, what happens? That steam is going to convert it into water again with help of a cooling medium. Okay, in the condenser, what we are doing here now? We are converting steam into we are going to convert steam into water. Again, with the help of pump, what we are doing? We are going to pump that water to the boiler. That means what? Initially it was water, finally it is going to reach the water itself. That means what? You can take a water, certain quantity of water, that is water we can take, then you can assume it as a system. That means what? It completes a cycle. That means what? The properties at the end, you assume that initially when you are taking water at initial condition, right, it is having an atmospheric pressure. You can take initial condition Pi. When it reaches back and you leave it for some time, right, it is going to attain its original pressure. That means what? Final pressure is equal to original initial pressure. Again, volume also is going to retain its final only. That means what? The volume, the state properties like pressure, volume and temperature, they are going to become identical both at initial and final state. That is known to be cyclic process, dear students. Now initial temperature and final temperature will remain same. This is what? An example for what? Cyclic process. Okay, fine. So what are the you can see the application of this Rankine cycle or Carnot cycle in our day-to-day life. You may ask, sir, where you can get the application of this kind of cycles? Yes, in the power plant you can see the application of gas power cycles. Either it may be Rankine cycle, Carnot cycle, or any kind of cycles you can take. There, that cycles are nothing but what? Cyclic process. You can see here now. Okay, fine. This is about cyclic process. Then what is non-cyclic process? That we will see here, dear students. Now what is thermodynamic non-cyclic process? Non-cyclic process is the one in which the system does not return to its initial state. But in the cyclic process, the system will come back to its original position, but the properties remain same. That is known to be a cyclic process. That is a continuous cycle process. But when it comes to non-cyclic process, the system will not come back to its original position. This means that the final state of the system is different from the initial state. That means what? The final state of the system is not at all same as the initial state. And therefore, what will happen? The thermodynamic properties like pressure and volume and temperature, and or you can take internal energy, they are going to change. They will not remain same as the same as it is in the cyclic process. But in non-cyclic process, the pressure, temperature, volume, they are not at all going to change at the end of the process. At the end of the process, or once the system reaches back to its original position. That is known to be a non-cyclic process. What is non-cyclic process? Non-cyclic process is the one in which system does not return to its initial state. How it is that? You can see here. Okay, so now initial state change. That means what? The system final state differs from initial state. That means what? The initial state and final state are different, but when it comes to cyclic process, both are same. Okay, and this non-cyclic process is path dependent. Okay, it is a path dependent and non-zero state function. That means what? Changes in the state functions are not zero. One thing, but when it is going to happen, right, non-cyclic process, there is a work and heat interaction will takes place. Okay, process involve work and heat exchange with the surrounding, but in the cyclic process, we can't say it is what work and heat energy is going to cross the system and it is going to enter into the surrounding, but in the non-cyclic it is going to happen. Okay, what is the major difference between cyclic and non-cyclic process? That you can see now. Cyclic process is a process where the system returns to its initial state and the state variables are identical at both initial and final state. That is what cyclic process. Whereas non-cyclic process where the system does not returns to its initial state. That means what? You can see now. The system, you can take it here now. This is a system, right? You assume it as a system. Okay, it will start initial point and it will reach state 2. But if it is not at all coming back to its original position, then that type of process we can call it as a non-cyclic process. If it reaches 1 to 2, again it has to come back to 2 to 1, and conditions are what? The state properties remain same at both initial and final state. Then only we can say it is a cyclic process. If it is not coming back to its original position with the same properties, then we can't say it is a cyclic. We can say it as a non-cyclic process. What are the examples, dear students, we can take now? When you are going to combust some fuel, right, we can take in your home. When you are going to lamp the light, right? Okay, so then what happens now? When we are going to have a fuel combustion, right, that fuel combustion, what it is going to do? It is going to convert reactants into products. That means what? Fuel products. You can take any fuel. It is going to have some carbon in it, oxygen in it, or you can take a methane. When you are going to burn with that oxygen, right, then what happens? That oxygen and methane, or you can take any hydrocarbons, they are going to burn, or they are going to form some other combustion products like CO2, CO, NOx, or soot, or anything else. That means what? The reactants will not come back to its original position. They become some other product. That is nothing but what? One example for what? Non-cyclic process. What is the non-cyclic process? What are the examples that you can see in detail now? Okay, so now these are some examples for what? Non-cyclic process. What are the examples that we can see here now? Heating water. When we are going to heat the water, right, we can take it now. Initially it was a water. Okay, water temperature increases. When we are going to increase the temperature of the water, I mean when we are going to add the heat, right, then what happens? Water will boil and that water will be converted into steam. Okay, the properties of initial condition, that was water, right, is changed, whereas the final properties of the steam is changed. That means the properties, they are changed. This is nothing but non-cyclic process. Gas expansion. Gas expand against pressure. You can see now, when the gas expands on the piston, right, then piston will start to move. That means what? We are going to get the work. Okay, that means what? It will not come back to its original position. That maybe heat may change or heat may dissipated to the surrounding. That is nothing but a non-cyclic process. Then chemical reactions, as I told dear students now, whenever you are going to have a fuel combustion, right, then that fuel is going to burn and it is going to convert the reactants into products. Like examples you can take now. Whatever the examples, that reactants you can see now. Methane, I will take one example here now. You can take a lamp. That lamp is running with a methane example. You are going to give methane. These are what? Reactants, and you are going to give oxygen as a reactants, right? When they both are reacted, right, they are going to form some combustible products, that is CO2 and H2O and heat. But we can't come back to its original position. Once the fuel burnt, right, then heat will be generated and hot gases will come out. But we can't convert back to methane or oxygen. If it's so, then that process we can call it as a non-cyclic process. Non-cyclic process means what? Heating. You can see here now. When you are going to heat the water, right? Heat the water, right? You can take water. That water is going to convert it into steam. Then we can't come back to its original position. But the properties at water is different. The properties of steam is going to different. That is nothing but what? Non-cyclic process. Dear students, hope you understood today's class. Okay, if you have any doubts, you can comment and you can ask. Okay, please subscribe my channel and support. Thank you. We'll continue next class.